Consider the two triangles. You can see that we have two of the three angles for both of the triangles. First thing to do is to work out the missing angle. So 30 and 70 gives us 100. The angles in the triangle add up to 180 degrees, so that must be 80 degrees. 70 and 80 give us 150. 150 plus 30 give us 180 degrees. Now, what we can then say is that the triangles are equiangular. And we can then say the ratios of the corresponding sides are equal. Triangles are equiangular, it just means they have the same angles. And triangles are similar. In example 2, we have two triangles. We're given all three sides for both triangles, but we don't have any angles. What we would do in a calculation of this sort is work out which side is the smallest, the intermediate and the longest side. Now, if I look at the first triangle, this is the smallest side, so I'm going to mark the angle here opposite the smallest side with an arc. If I go to the second triangle, 8 is the smallest side, so I'm going to mark that angle with an arc. The intermediate side on the first triangle is 8, so I'm going to mark that with a dot. And the intermediate side on the second triangle, I'm going to mark the angle opposite that with a dot. And that means that we have the largest side, 12. I'm going to mark that with a double arc. And similarly for this triangle here. Now, what we're going to do is to work out the ratio of corresponding sides. So if we take the smallest side, so if we go to the first triangle, the smallest side has a length of 4 units, and in the larger triangle has a length of 8, and 4 over 8 simplifies to 1/2. Now if we do something similar with the intermediate side, in the smaller triangle it's 8, in the larger triangle it's 16. And the last thing we do is we look at the largest side in the smallest triangle. The smaller triangle it's 12, and in the larger triangle it's 24. So you can see that these ratios are all the same. And we can conclude from that, so the ratios of corresponding sides are the same. That means that the triangles are equiangular. And that they are also similar. So example 3, we're going to do a calculation. We're told that the triangles are similar, which means that the ratios of corresponding sides must be the same. Now what does that mean? Well, what I'm going to do is to work out the scale factor, and that can be found using a simple formula, final over initial. Now I'm going to pair up this side on the first triangle with this side on the second triangle. We can either have, let's just have the 39 on top then, over the 13, which gives us a value of 3, scale factor of 3. What does that mean? It means that we multiply this, all the dimensions on the smaller triangle by 3 to get the dimensions on the larger triangle. And we're going to use that then. So if I multiply the 5 by 3, that will give me the value of x. So a simple calculation, x equals 3 times 5, and that's 15 centimetres. Example 4, triangles are similar, calculate the value of y. So first of all, calculate the scale factor. It's always final over initial. Now, we can either go from 20 to 5. In fact, I think that's what we'll do. We'll just take the 20 as the initial shape, the initial length, and the 20 as the final length. So if the final is 5, and the initial is 20, what do we get? We get 5 over 20, which is 1 over 4. Now what does that mean? It means that to get from the first triangle to the second triangle, we multiply each of the dimensions by 1/4. Now, we're going to have to do the same then with this y. So we'll multiply y by 1/4 to get 2. So 1/4 of y equals 2. Multiply by 4 to get rid of the dividing 4. Y equals 2 times 4, and that's 8 meters. So go to the textbook, and I'd like you to try, this is book 2, the yellow textbook, the one you were using for changing the subject, and page 51, questions